Today we are talking about graphing, and mostly graphing rational functions and sine and cosine functions. But what I want you to remember is that you always get to use your graphing calculator on the final. So this is going to be a quick review because I feel like most of these things you're going to be typing into your calculator, hitting graph, and interpreting the graph on your calculator. Okay, so let's get started. So first of all, what we're going to do is talk about rational functions. So rational functions, remember that rational is just fancy. Oh yeah, so I did this whole lesson already one time, but I didn't hit the right button, so I just had to ask my friend if I was really recording. So rational functions just means fraction. And functions, of course, you know that just means it passes the vertical line test, blah, 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 all that good stuff. Okay, so here's an example of a rational function that you might encounter. So x minus 2 times x plus 4 over, let's say, x plus 5 times x plus 4 times x minus 3. There you go. Look at all that fraction. So the important things that you guys need to be able to understand about this function is poles. Poles happen when things cancel out. So as you can see on this function, this is going to cancel out, so that means we're going to have a hole when x is equal to -4. And then you just kind of forget about that for a little while and come back at the end and put that in your graph. Then we need to talk about vertical asymptotes. After you look for holes, then you look for vertical asymptotes. And vertical asymptotes, remember, they're these things that go up and down vertically. They happen when the denominator is equal to 0. So in this case, it would happen when x is equal to -5 and when x is equal to 3. Okay, so another thing that we need to talk about is horizontal asymptotes. Now, horizontal asymptotes have two cases. Well, three cases actually. I'll get to that in a second. So this one, the case of this one is when the power on the bottom is greater than the power on the top. Now think about this number getting really, really big and this number not as big. Eventually, if you have a not very big number divided by a really big number, like 10 divided by 50 million, this is eventually just going to approach y equals 0. And that will happen every time the power on the bottom is bigger than the power on the top. So we have holes, we have vertical asymptotes, we have horizontal asymptotes. We need to find the zeros. And zeros happen when the numerator, the top part, is equal to 0. So after I cancel out that 4, the only other 0 I have is right here. So this is going to be at 2, 0. And then I also like to find the y-intercept. And I'm not really concerned so much with what exactly it is, just whether it's positive or negative. So if I plug in 0 to all these things, I get -2 divided by 5 times -3. So it looks like my y-intercept, two negatives are going to make a positive. So my y-intercept is 2 over 15, positive number. So then it's just a matter of putting all of this stuff on a graph. Da, da, da. So I'm not going to worry about the hole until the end. So -5. There's one vertical asymptote, +3. Right here, that's where the y-intercept is, so I'm going to be crossing the y-axis there. I have 0 at 2, 0. So this is the only place right here that I can cross the y-axis. Now the end behavior, which is horizontal asymptote, remember this is also talking about the end behavior. So that doesn't matter, this is the middle, so we don't care about that here. But at the ends, I'm going to put these zeros here at the ends. Now for your final, there's going to be no asymptote sandwiches, so remember your graph can never come on both sides. So I'm going to start in the middle, and I see the only chance I have here is to come up with a cubic, because I can only cross the x-axis in one place. So I'm going to sketch my cubic equation there. And then because I can't have an asymptote sandwich, the only thing that I can be is above the x-axis here, and then below the x-axis here. And then you might say, oh, right, that's great, that was easy, I'm done. But the only thing you have to remember is to go back at the end and plug in your hole. So at -4, I'm just going to go up here and I'm going to say there's my hole at -4. If you want to be really fancy, you could plug in -4 to these remaining x values and find exactly what it is, but I think we're okay with just this. Okay, so this was a case where the horizontal asymptote was at 0, when the power on the bottom was bigger than the power on the top. Case 2 is when the power on the bottom equals the power on the top. So for example, f of x is equal to 5x squared minus 8x plus 6 over 2x squared plus 17, something like that. So now see how the powers here are the same? So eventually, when we're talking about really big numbers for x, we're really only concerned with the biggest powers, because if I'm plugging in 50 million, these aren't going to make a difference, like adding 17 to 50 million, please. I would give everyone $17 if I had 50 million. So I just take my two biggest powers, I rewrite them, so eventually this function is just going to approach this. And then the x squareds cancel out, so eventually in the end, it's just going to level off to 5 halves. And then this would be your new horizontal asymptote. Not so bad, so you do everything exactly the same as you did right here, except this asymptote here would move up to 5 halves. You would have maybe different vertical asymptotes and stuff. Okay, case 3 was everyone's favorite. This is when the power on the top was bigger than the power on the bottom. And remember what we did, how excited you all were about this? You're like, oh, Miss Grandpa, I love doing these problems because you got to practice your long division. And nightmares from 3rd grade came back, and you're like, oh my god, I didn't think I would ever have to do that again. But, because I know that you sweat over these, I'm going to tell you right now, not on the final. Okay, so be sure that you know we're vertical asymptotes, horizontal asymptotes, holes, zeros, and y-intercepts. All right, now let's quickly move on to the graphs of sine and cosine functions. Now again, you get to use your graphing calculator for this, so I don't expect it to be very difficult for you. But quickly, because we haven't graphed one of these in a while, let's say I start off with y is equal to 2 times the cosine of 2 times x minus pi over 4 plus 3. So there's a couple things going on here. The first thing that you need to realize is all of this mess over here is just the shift. That's not going to affect the actual shape of the graph. It's just going to move it up, down, right, left, something like that. So what I'm doing is I'm just taking this graph 2 cosine of 2x, and then I'm going to shift it. Well, this shift means that you're moving it to the right, pi over 4, and then up 3. So let's remember what all these things stand for. This number in the front is the amplitude. So that means it's oscillating back and forth between positive 2 and negative 2, positive 2, negative 2, forever and ever and ever. And this is the frequency. So that means that it's going to complete 2 cycles in 2 pi. So if you want to find the period, you just do 2 pi divided by 2. And that gives you pi. And then remember from there, it's pretty easy. You just take the period, you break it up into 4 pieces. So here I have pi, pi over 2, pi over 4, 3 pi over 4. And maybe I'll go all the way out to 2 pi so I can get 2 cycles. 3 pi over 2, 5 pi over 4, 7 pi over 4. And I put my shift in. So remember, we're going to shift right pi over 4 and up 3. So there I am going to the right pi over 4 and up 3. shifted my axis to where this is my new origin. But remember, cosine starts at a max. So I'm going to go up 2 from there, and then the next spot would be down to the 0, and then down 2 because the amplitude's 2, up, back. Oh my gosh, this was so much fun, and remember how good you were at it, and it was so easy, and everyone got 100% on the test, and it made it really easy for me to grade. So basically, there you go. Remember, make sure, all you people that I had to argue with before, make sure that you finish your graph back to the y-axis. I don't like it free floating in the middle there. And that was basically all you had to do. So the only thing that's really going to change on the test is maybe you're going to end up with something like 5 times the sine of 3x minus pi plus 5. Okay, so the only thing that's different about this graph, everything else is exactly the same, but the sine, remember, starts at the... That's right, it starts at the origin. Okay? And if you have this number on the inside here, you have to factor it out. So it's 5 times the sine of 3 times x minus pi over 3 plus 5. So you're going to be graphing 5 sine of 3x that is shifted right, pi over 3, and up 5. Okay? So basically that's it. There's not going to be a lot of graphs with like tangents and cotangents and secants and stuff like that. But if you do have questions, remember you have your calculator, so use your calculator. And there are also going to be questions about trig word problems. But remember, that lesson is already on a video. So if you have more questions about trig word problems, then look at that video. It's the one where I have the really pretty hair. So enjoy watching that again, and I'll see you tomorrow. Have a great day.